In this lesson, we're going to use matrices to solve systems of equations. How many methods have we learned already to solve a system of equations? Three. What's one of them? Graphing. What's another one? Substitution. What's another one? Addition and subtraction. Okay. You can also solve them using matrices. Now, I'm going to be honest with you right now. Chances are you will not want to use matrices if you only have two equations like we've been having. But when you get into something where you have four variables and four equations, can you graph a line that has four variables? You could graph a line with three. You just have the x and y axis, you have the plane, and then you have the z axis that runs vertical through it. It's just a three-dimensional graph instead of two. But you can't graph something with four dimensions, so we need other methods. But we're going to simplify it and go ahead and show you how to use it with just two equations. All right, if we're solving 3x equals 7, what do we need to do to solve for x?
Divide by 3.
Okay. And if we divide by 3, we get x equals 7/3. What can we multiply by that's the same as dividing by 3?
Times negative 3. Times 1/3.
Times 1/3. If we have 3x equals 7, we can multiply on both sides by 1/3. Sometimes we call 1/3 the reciprocal of 3, right? But it is also the multiplicative inverse, and it's that inverse word that we're going to key in on today. We can multiply both sides by the inverse of that 3, because 1/3 times 3 is
0.
1/3 times 3.
1.
1. And 1 times x is x. What is the only way to get 0 with multiplying?
Times by 0.
Timesing by 0. You cannot multiply and get 0 unless you have 0 to start with. And then 7 times a third is 7/3. So one of the ways to solve is to divide, but another way is to multiply by the multiplicative inverse, and that's the thing we're going to focus in on today. Okay. When we want to use matrices to solve a system, what we start out with is we've got to put this in a matrix because it's not in a matrix yet, right? So we need to put this in a matrix. What we do when we put this in a matrix is we start out with a coefficient matrix. What's a coefficient?
The
number in front of the variable. So we have a 3 here. What do we have here?
1.
A 1.
-7 and a -4.
Okay. So we need them to be in this order. X, Y, X, Y. That's important. If they're not, can you rearrange them?
Yeah.
Yes. So we're going to put them in this order. 3, 1, -7, -4, just like they look. Then we're going to multiply that times the variable matrix. What are our variables in this problem? X and Y. Now we'll show you. That's fine to write it like this because look, we know we multiply row times column, right? So that would be 3 times X and 1 times Y, and we'd add those together. Is that what that says? Yes, so that works. That's okay. And then we write an answer matrix, which is just 6 and 1. Okay? Now I want you to do that for the second one. All right, so we want to do this one. Felicity, what'd you get?
I got 6, -5, 5, and 4, times xy equals 19, -4.
Yes. There we go. I have to figure out what's wrong with it. So all we're doing here is we're taking it from this into the matrix form, and that's it. And like I said, if it starts out where maybe you had 3x equals 6 minus y, and your y is on the wrong side, just add y to both sides and make it 3x plus y equals 6, so that you have it in the order that you want it, if it's not to begin with. Right? All right, put your pencils back down. Okay, this is the same matrix that I wrote down for the first one. 3, 1, negative 7, negative 4, x, y, 6, and 1. If I want to solve for x and y, I'm saying this is this matrix times my variable equals a number.
Yes, it does.
No, that's true.
Does that look something like what we had here?
Yes.
A number times a variable equals another number. But for us, instead of just a number, we have a matrix full of numbers times variables equals another number. So since we're not going to divide by a matrix, what we're going to do is we're going to multiply by the multiplicative inverse. So let me write that word down. We're going to multiply by the inverse. We don't talk about matrices having reciprocals. Numbers do, fractions do, but matrices don't. They have what's called an inverse, but it's the same kind of idea. Let's call this matrix A. Then what we're going to do is multiply on both sides by the inverse. We write the inverse A, negative 1. That's just a terminology kind of thing. And we're going to multiply by A, negative 1 over here. Do we know how to find A, negative 1?
Add them all together.
Okay, we don't know how to find the inverse of A right now. So this is somewhere where we're going to let our calculator do the work.
Yeah. I was writing down the problem.
I'll give you time to write it down in a minute. So we want to first put both of our matrices, our coefficient matrix and our answer matrix, we're going to put into our calculator. We remember how to do that. Second matrix, over to edit, into our 2 by 2. You don't need to put this one in yet, just watch me. And we're going to enter first our coefficient matrix, 3 and then negative 7. Why am I hearing the ticking? 1, negative 4. So our coefficient matrix is in there first. Get away from her. And now we're going to put in the other matrix. I have to arrow over to edit before I choose number 2. It's already a 2 by 1 matrix, which is what I want, and it's 6 and 1. 6 and 1. Okay. Now the first thing I want to do, why is it like that? I want to find the inverse of matrix A. So to find the inverse of matrix A, we go second matrix. Now we want to use it, so we just choose number 1. And then we use the negative 1 key, which is the same key as the matrix key. And when we hit enter, it's going to give us the inverse of that matrix. So we want to multiply 6, 1 by our inverse matrix, 0.8, 0.2, negative 1.4, and negative 0.6. Can we do this matrix times this matrix? How many do we have in this row? 1. How many do we have in this column?
2.
Can I do that?
No.
No. So what I'm going to do is see if it makes sense, oh dear, to do it the other way around. Stop. Okay. So I'm going to take this one and see if it works if I move it over here. 6, 1. Now can I do this row times this column?
Yes.
Yes. And so that's what I want to do. So let's do that now. Okay, so when we multiply, we get this matrix, and then our final matrix is 5, negative 9, which means 5 is x, and negative 9 is y, and we can write that as an ordered pair if we want, 5, negative 9, or we can write it as a matrix if we want. Either way. So now I'm going to let you do...
What did you just say?
All right, the other one. So we already have the matrix in here. This time we're going to use the calculator for the whole thing. So first we're going to input the coefficient matrix into matrix A and the answer matrix into matrix B. Remember to arrow over to edit.
How do you minus
It's a
the-
2 by 2 matrix is all that's saying.
Oh,
How many rows, how many columns? Yes.
I left the calculator on my locker.
So I input the coefficient matrix first, and I
Wait,
quit.
how do you take out a row?
You just change at the top. Let me show you. Here, you just edit it right in there.
Success.
Okay, 19.
And they're all 18. Wait, with this gonna be. Wait, how do you get out again?
Second and quit.
How do you get back to like? How do you?
Get back to where?
I'm confused. What's doing next? I have it in, but then what do I do with it?
Second and quit.
Wait, do we put the next one?
Now put in the other matrix. Yeah, you need both of them in there. You need both matrices in there.
No.
Now, when you find the inverse of this matrix, it's ugly, isn't it? Is that numbers that we can work with very well?
No.
No. But what do we want to multiply that by? What do we want to multiply the inverse by?
10. I don't know.
Okay, so we want to, our goal, once we put in matrix A and matrix B, we want it to multiply both sides by what? To solve for x and y, we want to multiply right by the inverse. So we're multiplying by a negative 1 on both sides. So in our calculator, since a negative 1 is giant, large, ugly decimals, we're going to let the calculator do all of this for us. We're going to do a negative 1 times b just using the calculator. So here is a negative 1 already in there. I'm going to do that times second matrix, choose the second one, matrix B, and that's going to give me my solution, negative 1, negative 5.
Mine said that I had an error.
If you did it backwards, if you tried to do B times a negative 1, remember how we said that wouldn't work?
I did A negative 1. A